Greetings, students. This is Mr. Torgerson. We're going to discuss 1.1 in your notes today. That's going to be pages 18, 19, 20, and 21. So pages 18 through 21 in your notebooks today we're going to discuss. Alright, so here's some key words. The graphs of equations, the set of all points that are solutions to an equation. This can be any type of equation. Absolute value, this is a review term. How far a number is from 0, for example. 2 and 5 are 3 apart. Now I know that 5 is greater by 3 than 2. So 2 minus 5 is actually negative 3. But the absolute value is the distance between two numbers. So we make it a positive 3 to signify that they're 3 apart. In other words, 5 is 3 greater than 2. Regardless of which way this is written. 5 minus 2, 3, 2 minus 5, 3, because 5 is 3 greater than 2, and that's what absolute value means. That's what we're saying here underneath. The absolute value of A is equal to A if A is bigger than 0, which would be the case if this was 5 minus 2, or the opposite of A if A is less than 0, which is the case here. 2 minus 5 is negative 3, but we choose positive 3 here because absolute value is the distance between two numbers. Okay, so let's go to our first set of examples. Determine whether the point lies on the graph of the equation. What I'm asking here is the point a solution? Is it a solution? So, sorry, my writing is horrible some mornings. It's a solution. Meaning you can substitute the x and y coordinate in for x and y on the equation and see if it works. So this first item here is x, the second item is y. So we're going to replace the y with the 8. So when I replace this 8 into the y, it's going to say 8 is equal to. I'm going to put a question mark above this equal sign because I don't know if it's equal to or not. That's the whole point of this question, to see if it's equal. So I don't know yet if it's equal. I'm trying to see if it is or is not equal. The quantity negative 2 squared. Now why the quantity? Because when you substitute items in to equation, you always use a quantity symbol. I could have used parentheses around the 8 as well if I wanted. Minus 3 times the quantity negative 2 plus 2. Alright, so recall when you have a quantity symbol, you do the operation first. So negative 2 quantity squared is positive 4, not negative 4. So again, the question here is, does 8 equal? So that's what I'm writing here with this equal and this question mark. Does 8 equal? I'm not stating that 8 equals. I'm asking if 8 equals. 4, negative 3 or minus 3 times negative 2 is positive 6. Because there's two minus signs there. So does 8 equal 4 plus 6 plus 2? And here, I can validly answer the answer no. 8 does not equal 12. If this had been a minus 2 here at the end, the answer would have been yes. We would have stated yes for our answer. But no is our answer. So, does negative 2, 8 lie on the parabola y is equal to x squared minus 3x plus 2? The answer here is no, because 8 is not equal to 2. So this is a yes or no answer. Meaning when you get to here and you say 8 is not equal to 12, you're not finished here. You answer the question yes or no, based on if it in fact equals or not. Alright, next example. Similar question. Here's x, here's y to replace. So y is going to be replaced by a minus 4 or negative 4. Again, I can use parentheses here if I prefer. Because it's just a y, I'm not going to bother with parentheses because it's on by itself. It's isolated on the left by itself. So does 4 equal, again this equal with a question mark is asking does it equal or not. That's what the question is asking. Positive 4 minus the absolute value of negative 6 minus 2. So I'll put a parenthesis around the negative 6 here. And then I'm going to evaluate what operations to do first on the right side of that equation. So I'm looking at that right side of the equation. And I'm seeing an absolute value bar, I'm seeing a parenthesis with a negative 6 and then a minus 2 next to it. That's what I'm seeing here. So some of you are thinking distribution here, to distribute the negative into the -6 and the -2. The issue with that is absolute value is done before distribution. In other words, what's inside the absolute value comes before distribution. This is not the same as a parenthesis, an absolute value bar. In other words, the negative should not be distributed inside of here. Now, in this particular case, it's actually not going to affect our answer, whether we distribute that negative or not, or particularly. But in many cases, it will affect your answer. So just keep that in mind. So what I'm going to do first here, I'm asking, does 4 equal the question mark? And sometimes I get a little bit sloppy with that, equal question mark. 4 minus, we're going to remove this parenthesis around the -6, it's unnecessary. And then we're going to take -6 minus 2 to yield -8 inside that absolute value bar. So does -4 equal, now when I'm writing down all of these steps, many of you do not need all of these steps. That I recognize. My main purpose behind writing all of these steps is to explain every single thing that I could possibly think of on the question here. So that actually does not become a plus. Again, this negative does not distribute and make this 4 plus 8. This -8 inside an absolute value is the same as this -3, or -3 inside this absolute value. This becomes a positive 8. And the answer to this question is actually a yes. This becomes 4 minus 8, because that becomes a positive 8 right there. And that negative stays in front. So does -4 equals -4? Yes. So that's how I would write that. Yeah, -4 equals -4. Yes, is the answer to this question. So that illustrates some of the complexities of absolute value, where you don't distribute a negative sign into an absolute value expression. You do not distribute this negative into the absolute value expression. You take the absolute value first and then take its opposite. Moving along. So the next thing we have is graphs. So there are a few different ways to do graphs. And the first way we're going to do is a table of values. Because you can use a calculator, you're welcome to use a calculator. There's various options. Desmos is a very good option for using calculators to get a table out of a calculator. Most of you will not have access to the regular TI-84 calculators, which is what we usually use, but Desmos is an excellent option if you'd prefer to do that. There's various other graphing calculators available online for free of charge, that you can use here to plug the numbers in for X and find the outputs for Y. I do not expect these to be done by hand. I'm going to repeat that. I do not expect these to all be done by hand, these plugging the X's in. So what happens is, each of these replace X one at a time, and we find the corresponding Y value. So let me illustrate the first one. -4 goes in for X, the X value -4. So we have Y is equal to half, parenthesis, -4 plus 1. So for my first X value, half of -4 is -2. And then we add 1 to that, and we get -1, sorry. So this Y value is -1. So my first coordinate as a pair is -4, -1. In other words, it's left 4, down 1. 1, 2, 3, 4, down 1. That's my first coordinate right there. Alright, my second coordinate, I do a similar thing. Instead of plugging in -4, I plug in -2. Let me use a different pen here. So for my second coordinate, I'm going to switch to a reddish pen. I would have Y is equal to half of -2 plus 1. Well, half of -2 is -1 plus 1 is 0. So this Y coordinate is 0. In other words, this coordinate is the left 2 up 0. left 2, up 0. Now again, I'm not particularly looking for this work right here. It's useful for some of you to show that workout because some of you need practice plugging in points. But again, we can use a calculator all year long, so if you prefer just use a calculator to get these values out, that's fine with me. This next value should be a -1. So there should be 0, -1. Oh, I made a big mistake here. I'm going to point it out right now. Some of you, as I've been going through this, have noticed this already. So I'm not going to cut this out of the video because I make the mistakes all the time. And I don't want you to think that I don't make mistakes. This was supposed to be -1 for all of these expressions. These were supposed to be minuses. This first value should have been a -3, not at -1. 1, 2, 3. And this second value should have been at -2. Should have been -1, -2. So it should have been here because it was -1 in the original expression, or original equation, sorry. Expression doesn't have an equal sign, equation does. So I left that in. So again, that's a -2 and a -3. Not the original -1 and 0 that I had there because it was not +1 at the end. Alright, our next value here should be located at well, the x is 1. Oh, this one's actually fractional. So here's an interesting concept here. I have 1/2 minus 1. That's a -1/2. So this is an example of plotting a fraction. So that's 1 comma -1/2. So here, and then it's just halfway in between. That's a -1/2. And then our final finishing value here on this particular graph is at 2 and 1, or 2 and 0, sorry. And I know a lot of you are thinking, well, I could do this table using the concepts of slope-intercept form, and that's particularly fine with me. We were just illustrating how to do a graph with points here, with a table. And I'm not particular, because we're not testing in person, it's all online tests anyways and quizzes right now. I'm not particular if you would prefer to do this particular type of graph using another method, especially since this is in slope-intercept form for a line. If you prefer to use that, that's perfectly acceptable with me. I have no problem with that. Alright, so there's page 18. Page 19. The two advantages of the table approach. It's always the same. You plug points in, you get points out. So we always have the same. Always the same. Second advantage is this is the way a calculator graphs an equation. This is the way a calculator does it, because a calculator doesn't know what type of equation you've used. When you plug it into calculator, this is the way a calculator graphs, the way most calculators work. And when I say most, there are some that do different things with equation graphs if they can recognize certain aspects of an equation. The two disadvantages of this two major disadvantages of this approach. The first major disadvantage is that it takes time. It's more time consuming. As you saw from this approach, most of you can graph that line much more quickly using slope-intercept. It takes more time. And the second main disadvantage of this approach is sometimes it's ineffective. You have to choose points carefully. So sometimes there's fractions. And by sometimes I mean you have to choose your points effectively. And if you don't choose your points effectively, you'll end up with a fraction. So what I'm talking about here is this point here of 1, half of 1 is a fraction. So when I chose this as my next value on my table, basically what I'm saying when I chose this as the next value on the table is that I want to have a fractional answer. Is what I said to myself. Rather than choosing a 2 here, where I could say, how well, half of 2 is 1, and then having a 4 here, I chose a 1 and said, well, you know what, I don't care if I have a fraction, I can deal with the fraction. So those are the two main disadvantages of this approach. You will have fractions sometimes if you choose your points in a certain way, or if you don't choose your points in a certain way, I should say, because you have to actually choose your points not to have fractions. Alright, the next way to graph is intercepts, x and y intercepts. Now this works for many equations, particularly lines, but for some equations that are more complex, it will only give you a window of the graph. It'll only give you a little bit of a clue of what the graph looks like. Alright, so an x-intercept is a point in which a graph intersects the x-axis. So it looks like this, x comma 0, where x is a number, any number, can be fractional, decimal. So for example, 4 comma 0, that's an x-intercept, would be right 4 up 0, right 4 up 0. Alright, so to do this, to find an x-intercept, you put 0 in for y. And the opposite is true for the y-intercept. So for example, 0 comma 3 would be up 3. 0, 1, 2, 3. And you would plug in 0 for x to find that. Alright, so create a function with only an x-intercept. So this could be a parabola opening to the right or left, or it could be a vertical line. So a function with only an x-intercept, let's say my x-intercept is here at 4 comma 0, 1, 2, 3, 4 comma 0. There's my x-intercept. For it to be a function, it's actually got to be, oh, it says function. That's an interesting concept. I should reword that instead of the same function because this is not going to pass the vertical line test. I should reword that instead of saying function to say something else because it's much easier to do sideways facing parabola here than it is to get an actual function. But for this here, I'll make it so it is actually a function, and I'll say it's a portion of a line that points upward but does not go downwards. So a ray, in other words. This could be a function with only an x-intercept. Again, I'm saying that it does not extend down and cross the y-axis, because it would extend down if it was a full line. And we'll talk about the word function later on. I had to do that for a particular reason, for that to be a function. And then here, another one for a function for y, with only a y-intercept. Let's say it's down 1, 2, 3. And then this is much easier. I can do a parabola pointing downwards, or I can do a horizontal line here too, which would satisfy the function test. But let's just do a parabola pointing downwards. So that has only a y-intercept where it crosses the y-axis, and my parabolas do look weird. I probably should have just plotted 3 points there. Hopefully you get the understanding of what the general concept is here. Alright, so two other names for x-intercepts are solutions and zeros. So oftentimes when we're saying to solve an equation with a y equals, that's what we're talking about. What's the solution for x? Where does it cross the x-axis? And then also when we're saying find the zeros, we're talking about the specifics where y is equal to 0, not where x is equal to 0. So name a function that has both an x and y intercept. So this would be any example of a line besides vertical and horizontal. So for example, y is equal to 3x minus 2 would be a perfectly great example. Crosses the x and the y axis. Now it can cross multiple times as well, so a parabola would also work. So you could also, from your parabola questions from last year, you could also say y is equal to x squared minus 3, where it would be down 3 at start and then it would point upwards. X squared minus 3, or x squared minus something would work there as well. So it can cross the x-axis twice, or the y-axis twice. Actually, the y-axis twice, no, it does not work. We want a function here. Again, we'll get to the keyword function another day. So we would want an x-axis one where it crosses the x-axis twice, not the y-axis. Alright, so that's page 19. Alright, page 20, we're going to do an example of finding intercepts. So finding the x-intercept, what we do here, again, is we put in 0 for y. Oop, right there. 0 for y. So this should look in the form of, the answer here should be of the form x, comma 0, where x is the number and the y value is 0. So what we're going to do here is substitute 0 for y. And here I'm using the equal sign because I'm asking you to solve this. I'm not using an equal with a question mark this time like I did on the front. So when I'm substituting these values in, this value here, I'm saying what does x equal here? And that's going to be replacing this x in the coordinate pair. So here I've got 0 is equal to x plus 3 quantity squared. So to solve this, I'm going to start off by square rooting both sides or by foiling the right side. Now if I foil the right side, it's going to end up with more work because then I'm going to have to do the quadratic formula. So what I'm going to do is I'm going to square root both sides. Now keep in mind, if this was not 0 equals, we'd have two answers here. But the square root of 0 is only 0. We can't have a negative value there. And what I mean by negative is because this is a square root of both sides, there could be two possible solutions if this was not a 0. That'll come up not today, later on, but another day. So 0 is equal to x plus 3. Well, that means that x is negative 3. In other words, our x-intercept is at negative 3. Negative 3, comma 0. The x-intercept should always be of this form, x, comma 0. It should not have just a number, just an x equals negative 3. Because that's the solution for x. That is the solution or the 0, which we talked about right here. The solution for x or the 0, but that is not the x-intercept properly written. This is the x-intercept, negative 3, comma 0. It's just a little bit of a little key there, a little bit of a key in words, you would say. Alright, find the y-intercept. Well, this we're going to have of the form 0, comma y. So here I'm going to have y is equal to y, and then x is going to be replaced by the 0. 0 plus 3 quantity squared. Now again, this is going to be done inside first from order of operations. So y is equal to 3, the quantity 3 squared. So that means y is 9. And now again, when I get this y equals 9, that is this, y is not even a solution of 0. That's a y-axis crossing. That's 0, comma 9. That does have a name. I've just forgotten it this morning when you get this y equals 9. Just like this is a 0 or solution. That one does have a name. I forget what you call that. The y equals 9 part of it. Anyhow, that looks like a weird P there. It's a parenthesis. 0, comma 9 is the y-intercept there. And what you could use those for is for the graph. So the x and the y-intercept are useful for the graph in determining where the graph goes. Like I said, it just gives you a snapshot, however, what the picture of the graph would look like. So when I do negative 3, 0, again that's left 3 up 0, and I do a point of the x-intercept, and then I do 0, 9, that gives me kind of a snapshot of, well, this is kind of what the graph looks like, but I kind of have to figure out is there anything else that the graph does there? Because I can't just connect these 2 points and say, oh, it's going to be a line, or it's going to be a U-shape, or it's going to be a snake, or whatever, you know. So from there, I would do a few other points, and I would verify, you know, what does this graph actually do. So what I notice here is that the intercepts are 3 apart, negative 3 and then 0. For the x equals negative 3 and the y-intercept of x being 0. So what I'm going to do is I'm going to start my table at negative 6, because that's 3 to the left of what this value was, which was 3 to the right of my x-intercept. And I'm going to see what happens when you put in negative 6 for x. Again, you can do this on the calculator. You don't have to do this part by hand. So negative 3 squared. This is going to be y equals 9 as well, because it's negative 3 quantity squared. It's not negative 9, positive 9. Negative 6 plus 3, negative 3, quantity squared, positive 9. So what I'm noticing here is that these two values are repeated values. So that gives me a very good idea that this graph is going to point upwards on both sides. And I'm going to go through this point down below and point upwards on both sides, since these are evenly spaced from this x-intercept. I can check a few more values if I want to be for certain. So I could check negative 4, which would be right here on the x, and it would be quantity negative 1 squared, which is 1. So that's here. And then I could check negative 2, which would be positive 1 squared, which is also 1. So that there tells me for sure that yes, this is a parabola or a U-shape pointing upwards, coming down and kissing the graph at negative 3, the x-axis at negative 3, just coming down and kissing it. So with this table again, you can do it by hand or you can do it using a calculator. Desmos again is a particularly good calculator for these types of questions, where you would just type this part in and it would give you the graph out. Familiarize yourself with some sort of graphing utility, please, over the course of the semester, if you have not already last year. Alright, symmetry test. For symmetry, if it has y-axis symmetry, if you plug a negative x in for x, the equation will be the same. In other words, the left and the right of the y-axis is the same. Negative x plugged in for x is going to be the same. For the x-axis symmetry, plug negative y in for y, the equation will be the same. And for the origin, you plug negative in for both, and the equation will be the same. Alright, so we're going to use the above to determine if this is symmetric to either axis or the origin. X minus y squared equals 0. So we can solve this for x, we can solve this for y, or we can leave it the same as it is to start off the general test. The general tests, I should say, the 3 different tests. So I'm just going to leave it the same. I'm going to see if the new product, the new item, comes out the same as this. So if I plug in negative x for x, in other words, if I replace this x with a minus x, does the equation change? So when I replace x with negative x, so symmetric to the x-axis, excuse me, the x-axis first, sorry, I switched this to the y-axis, plug negative y in for y, does the equation stay the same? So what I'm saying here for the symmetric with the x-axis, replace y with the opposite of y. So when I place y with the opposite of y, it becomes x minus the opposite of y squared is equal to 0. Sorry. Probably should have got some water before I sat down. The opposite of y squared is still positive. This part comes before the negation. Again, this negative doesn't distribute in here. The squared comes first. So this is still x minus y squared equals 0. Yes. This has x-axis symmetry. Again, I switched them around. Alright, so y-axis symmetry. Replace the x with negative x. Or the opposite of x. So then the equation becomes the opposite of x minus y squared equals 0. Well, this opposite of x doesn't have anything there to cancel out its negative. It's not being squared like the y was. The y was being squared. The x is not being squared. So this changes the equation to become negative x minus y squared equals 0. That is different from in front of the x. So here we're going to say no. And I'm pointing to the part that defines it as no. That right there, where it says opposite of x instead of the regular x. For symmetry to the origin, we do both of these. We replace y with negative y, replace x with negative x. And most of you can see what's going to happen here. The answer is going to be no. There are very few graphs that are symmetric to more than one of these. But there are some that are, specifically circles, centered at the origin, but there are very few that are. So negative x, sorry, we replaced y with negative y. X, negative x, minus y squared equals 0. So again, the answer is no, because that x is a different sign. And what we have here is the graph of a parabola facing to the right. So if you understand what this graph looks like, this graph here has a center of 0, 0. I'll graph it underneath. Graphing this is not part of the question, but it does help explain the question. So graph centered at 0, 0 with it facing towards the right, like so. So to re-explain symmetry to the x-axis, what that means is it can flip across the x-axis. This is from a geometry concept. It can flip or fold across the x-axis. So you see this folds on top of itself on the x-axis. For the y-axis, it would have to fold across the y-axis on top of itself. And you can see if this folds over, it's just going to make a new parabola facing to the left. It's not going to fold over on top of itself. That's why it doesn't have y-axis symmetry. And then for the origin, they'd fold diagonally through the origin. Would be the proper keywords there. All right, that's page 20. One more page, page 21. It's only got a couple questions. Let me go quickly grab a sip of water, and I'll come right back. So, circles. Equating the circle with the center at the origin has nothing next to the x and the y. If it does have a center that's not the origin, it has a value next to x and y. This value at the end is what's called the radius. So this is the radius of the circle. This h and k is what's called the center, h and k. So h goes here next to x, k goes here next to y. And they're always opposite of what's written. So this is next to x and this is next to y. So what I like to do here with circles, I like to write down on the right side of the graphs each of the three values. H is equal, k is equal. Then notice this says r squared. So I usually write r squared is equal. So for my first value h, I'm going to look over here next to the x. I'm going to see if there's a value next to the x. This is where h should be. That's where h should be. Well, there's nothing there. So because there's nothing there, h is a 0. There's nothing next to this x value. The similar thing happens with this y. Next to this y value is what the k value is, or what k is. Now because there's nothing next to that y value, that's a 0. And then this is r squared. So after I do that, underneath that, I'm going to write down what the center is. The center is the coordinate of h and k paired together as a coordinate pair. So the center here is 0, 0. H is here, k is here. The center at h, k. That's the middle of the circle. We mark this with a coordinate point. Now this point is not on the circle, it's a graphing aid to make the circle. So this is not on the edge of the perimeter of the circle. Alright, then this r squared, this is the square value for r. So the radius is actually not 16, it's the square root of 16, only the positive root. So if we were looking to actually square root both sides here, this would be positive and negative 4, this 16. Because 4 squared is 16 and negative 4 squared is also 16. But we're only looking for the positive value here. That's why we're only using positive 16 underneath the root symbol. Because graphs can't have, anyways, because distances aren't negative is what I meant to say. So that 4 represents going up 4. These points are now along the perimeter of my circle, or circumference, if you want to use the proper words. Circumference of a circle is the same as perimeter, but it's the proper word for perimeter of a circle. And then those 4 points are going to make my circle. Now when you're drawing your circle, you just draw your circle your best you can around those 4 points. It does not have to be perfect. We're not having to use a compass here. We're just connecting the 4 dots with the best circle we can make by hand. And that is the equation of that circle and the graph of that circle. Now this would have symmetry with the y-axis. It can fold over the y on top of itself. With the x-axis, it can fold over the x on top of itself. And with the origin, it can fold diagonally on top of itself. You can fold the paper all the different ways. Diagonally, up and down, left and right. So if you want to talk about that question we just got done with, this has symmetry with all of them. Because if you replace x with negative x, it stays the same. Replace y with negative y, it stays the same. Alright, second circle. So this one does have an h value and a k value besides 0. This x minus h again signifies the opposite. So this is a minus 2, meaning that h is positive 2. If you want to think of it as what makes the expression 0, x minus 2, what makes x minus 2 0, that's a proper way to think of it. So 2 makes that 0. Therefore the h value is 2. Or if you want to think of it as the opposite of what's written, that also works. Most of the conic equations, conic functions, they work this way, where you take the opposite of a value of h and k. That's why we're presenting circles here first. K here is negative 3, because this opposite of 3, or you could say negative 3 plus 3 is 0. So therefore k is negative 3. And then my radius squared is 4. So therefore my center, where I'm going to start, and again this is not on the perimeter or circumference of my graph, this is just the center of the graph, is at 2, negative 3. 1, 2, 1, 2, 3. And then my radius is the square root of 4, just the positive root. We don't need the negative root here, which is 2. So from this point 2, negative 3, I'm going to go up and down, left and right 2. Up 2, down 2, right 2, left 2. It looks kind of like a keypad, up, down, left, right, with a period in the center, if you want to think of it that way when you finish it. And we can make the circle. Now here's an interesting comment on this one. This one does not have symmetry. So if you notice with this one, it does not have symmetry with the x-axis, does not have symmetry with the y-axis, does not have symmetry with the origin as well. That's mainly because its center is not the origin on this particular circle. Anyways, so if you want to write a reflection underneath in your notes, you can reflect on the notes. It's useful for you to go through your notes and figure out what you don't understand so you can ask it during class. Put a check mark by what you know you understand, what you remember from last year. Put a question mark on what you want to rework or watch again. And put an X on the ones that you just completely do not understand at all, that you want us to talk about in class together again. And when you do that, just come and ask any of your teachers, this is the one I will need help on, example 6A or 6B or whatever example it is. Alright, for the homework, we're going to post the homework as a book page in the homework assignment. So don't worry about writing it here. This is just for if we were having physical class, since we use these for physical class. And that's it for this lesson. Thank you.